Hello, thank you for joining our presentation today as we are going to discuss about the topic of software measurements and metrics. First and foremost, let me introduce my team members. My team members are Deeya, Shivika, Karan and myself Savindya. Our group selected SonarCube as our code quality management tool. SonarCube is a powerful tool for ensuring code quality in software development projects. It automatically reviews code for bugs, code smells, and security vulnerabilities, providing valuable insights to developers. Its customizable rule sets and detailed reports can make an essential tool for teams looking to maintain high-quality code and deliver reliable software to their users. SonarCube's latest version 10.4.1, released on February 23, 2024, underscores its commitment to ongoing improvement and innovation in code quality management. With this update, users can expect enhanced features, bug fixes, and performance optimizations, further solidifying SonarCube's position as a leading tool for ensuring code quality in software development projects. Prior to the latest release, SonarCube version 9.9.4 released on February 20, 2024. While this version may have lacked some of the features and improvements introduced in the latest release, it still provided valuable code quality management capabilities to users. SonarCube is a top-notch platform that keeps getting better with each update. Every new release focuses on making code analysis easier and more effective, helping developers catch and fix problems early on. These updates bring in new features, make things run smoother, and iron out any issues, all to give users a better experience.
Now let's explore some of the supported technologies and platforms of SonarCube. First, let's begin with the operating system. So SonarCube is actually cross-platform tool designed to work with a variety of operating systems. Thus, it supports Windows, Mac OS, and Linux, allowing it to integrate seamlessly into any development environment. This OS flexibility also makes SonarCube accessible to a diverse group of development teams. Now, moving on to the IDE and development tools. So, SonarCube integrates with most leading integrated development environments such as Eclipse, IntelliJ IDEA, and Visual Studio. So this integration actually brings code quality analysis directly into the development workflow. Thus, it actually enables the developers to detect and fix issues in real time within the comfort of their own preferred IDE. Now moving on to the build tools compatibility. So it is compatible with the Maven, Cradle and Ant, and this compatibility allows SonarCube to fit into existing build pipelines, thus providing automated code quality checks, and that can be run as part of the build process or in continuous integration pipelines. Now moving on to the version control system. So SonarCube actually supports a wide variety of version control systems such as Git, SVN, Mercurial, and as well as platforms like GitHub and Azure DevOps. This support ensures that SonarCube can actually analyze code in the VCS of your choice, thus maintaining a high standard of code quality across the various version control systems. Now moving on to the programming language support. So SonarCube actually has a wide range of programming language support. It supports about like 30 programming languages. Some of the major ones are Java, C Sharp, Python, C++, or JavaScript. And due to its ability to analyze code across multiple programming languages, It is able to fit into almost any development project. Thus, it is a versatile tool for software teams. Now, lastly, looking into the database support. So, SonarCube can interface with various databases, including MySQL, SQL Server, and Oracle. This database support is crucial for projects where code interacts with data layers, allowing SonarCube to analyze the stored procedures, the functions, and other database code to ensure the quality and the security. Now let's look at the popularity of the tool. So SonarCube's popularity in the market is actually substantial, as evidenced by its wide adoption in the software development industry. So, our first point of focus is the public interest in code analysis tools as captured by the Google search trends. So, since 2016, SonarCube has consistently maintained the highest levels of search interest compared to its alternatives, as you can see in the graph. This enduring interest over the years is indicative of SonarCube's strong presence in the market and also its reputation as a leading solution in code quality management. Let's look into the market share of SonarCube to know more about its popularity. So as you can see, SonarCube commands an impressive 94.53% of the market. This is a huge figure that emphasizes its dominance. Its nearest competitors, Fabricator and Atlassian Crucible, hold only 4.81% and 0.55% respectively, with also SonarSource at 0.07%. This is a huge difference. Such a commanding lead demonstrates SonarCube's overwhelming preference in the industry. SonarCube's search interest and market share paint a clear picture of its popularity. It's not just a tool, it is the go-to standard for code analysis in software development, and it seems like it stands out as the preferred choice across the globe.
SonarCube, a widely respected tool for maintaining code quality, has been embraced by major players across different industries. Take Starbucks, for example, which integrates SonarCube into its development process to ensure the reliability of its software systems, enhancing customer experience. Similarly, Ford utilizes SonarCube to bolster its testing protocols, ensuring the safety and performance of its automotive technologies. In the realm of technology, IBM and Samsung Electronics both rely on SonarCube to conduct comprehensive code analysis, guaranteeing the quality and reliability of their software products. Agoda, a prominent player in the hospitality industry, leverages SonarCube to maintain high standards in its software solution, ensuring seamless booking experience for customers. Additionally, Oracle incorporates SonarCube into its development workflows to uphold the integrity and efficiency of its diverse range of software applications. These examples highlight SonarCube's widespread adoption and its crucial role in ensuring performance and integrity of software across various sectors.
For purpose of tool of SonarCube, so the main point of SonarCube is that it is a self-managed automatic code review tool that helps to systematically deliver clean code. So it's basically standard of all codes that results in secure, reliable, and maintainable software. As such, essentially, it maintains a healthy code base. It provides integration for existing workflow and detects issues in codes to help perform continuous code inspections, as it can analyze up to many different programming languages, and it ensures that the code meets high quality standards, which allows the results to be secure, reliable, and maintainable software, as it helps in automatically finding bugs and issues in the code as well. Features of tool for SonarCube is one, multi-language support. It offers analysis for more than about 27 programming languages, which include Java, C Sharp, C, C++, PHP, and what it does is that it can help identify a wide range of issues in code, including standard violations or potential vulnerabilities and performance issues, as it helps in detecting a lot of problems. As such, also bug detection. Bug detection as a, it can in it can detect various types of tricky issues in the code which were mentioned in as such as like put standard violations, and it also helps in detecting security or coding practices mishaps. um, Third is integrations with CI and CDs, which are continuous integrations and continuous deployment, which enhances code quality and security checks throughout your software development lifecycle, which also includes IDE integrations. Is that it helps improve the quality of the code by providing real-time code analysis and feedback from integrated development environments, and it helps to identify issues early in the development stage as well. Fourth is track code smells. So code smells are different from bugs, as bugs are instances that are faulty code. However, code smells are codes that run okay but impede maintenance for one reason or another. So SonarCube has areas where it's able to detect or at least track code smells, which helps find out where the issue could be, and it makes it easier to have to be able to negate it. Last would be extensible plugins, as plugins in SonarCube are extensions that enhance the platform's functionality by adding additional rules, integrations, features, and you can think of plugins as adding extra tools to your toolbox so that you can have more features that you need, that which doesn't require you to have another system all on its own, where you can just add it onto SonarCube's features as well.
Okay, in the following discussion, we will embark on detailed comparison between SonarCube and Jenkins, exploring the advantages and disadvantages. We are going to look into various aspects and compare them accordingly. So first we're going to look at the advantages of SonarCube and Jenkins across various aspects, which are automated code analysis, customization and extensibility, open source, and rich plugin ecosystem. Looking at the first aspect, automated code analysis, for SonarCube, it streamlines development with automated analysis. So it elevates the development workflow by implementing automated analysis, which proactively scans for problematic code patterns and security vulnerabilities. This not only streamlines the process but also significantly enhances code quality by providing developers with actionable feedback and insights, enabling them to make corrections before code is merged into the main branch. Looking at Jenkins, provides continuous integration capabilities, facilitating automated build and testing processes. So Jenkins serves as an automation powerhouse in the continuous integration sphere, allowing for seamless build and test cycles. By automating these processes, Jenkins detects integration errors early, thus facilitating a more robust and reliable delivery pipeline. Its ability to trigger builds, run tests, and manage artifacts through each commit ensures that softwares can be delivered at a higher velocity with increased confidence in its stability. Now looking at the second aspect, which is customization and extensibility. For SonarCube, it's flexible customization of analysis rules. So SonarCube is highly versatile in its ability to be customized, catering to unique project specification with its users defined rules, and quality gates. Teams can adapt SonarCube's analysis algorithms to fit their particular coding practices and application requirements, leading to be more precise and relevant quality assessments. Now looking at Jenkins, highly customizable through the use of plugins allowing for extensive integration and customization of workflows. Jenkins' adaptability is unparalleled due to its extensive plugin architecture. The architecture provides the scaffolding needed to create complex, customized pipelines that can encompass various tools and languages. Jenkins can evolve with the project, accommodating new technologies and processes, which is particularly beneficial in a fast-paced and ever-changing software development environment. Now looking at the third aspect, which is open source. So for SonarCube, available as an open source platform. So SonarCube as an open source offering, it is not just a tool but also a platform that fosters community-driven approach to software quality. Developers can extend, improve, and integrate into the projects with ease, benefiting from community support and shared expertise without a financial barrier to entry. Looking at Jenkins, it's free and open source, fostering community innovation. So the tool's open source nature means it has become a canvas for innovation contributed to by countless developers worldwide. Its longevity and evolution are testaments to the strength and creativity of the community that has formed around it. This environment not only encourages but thrives on collective problem solving and feature development. Now looking at the final aspect, rich plugin ecosystem. So for SonarCube, extensive set of plugins available for customization. So with an expensive set of plugins, SonarCube can be molded to fit a multitude of development environments and programming languages. This plugin can introduce new features, connect to additional systems, or provide integrations that enhance the utility of tool beyond its out-of-the-box capabilities. Looking at Jenkins, over 1,000 plugins for extensive customization. So the sheer volume of plugins available for Jenkins speaks to its role as a central hub in the CI/CD ecosystem. Whether it's integrating with version control systems, enhancing user management, connecting to cloud resources, or providing notifications, the Jenkins plugins ecosystem serves as a comprehensive toolkit that can be leveraged to, to craft tailored CI/CD workflows for diverse application needs. So to sum up, SonarCube enhances code quality with its robust analysis, while Jenkins automates the build and delivery processes. Both offer rich customization through their plugin ecosystems and are bolstered by their open source community. Used together, they form an effective alliance for teams aiming for high quality, efficient software delivery. Next, we are going to look at the disadvantages of the tools through various aspects such as learning curve, challenges with integration, time consuming reviews, plugin dependency and management, and finally, management complexity. So the first aspect is learning curve. For SonarCube, it has a steep learning curve. So SonarCube demands a considerable investment of time and effort to fully understand and utilize its features. For developers not already versed in static code analysis and quality metrics, it requires acclimatization to both the terminology and methodology used within SonarCube to gain the full benefit of the tool. Looking at Jenkins requires developer skill but relatively easier. So in Jenkins, it is necessary to have a solid grasp of continuous integration concept and familiarity with DevOps practices. Though it might be more accessible for those with prior CI/CD experience, mastering Jenkins, especially its groovy-based scripting for pipeline, can still present a formidable learning curve. Now looking at the second aspect, which is challenges with integration. So for SonarCube, complex integration with CI/CD pipelines. So the complexity of integrating SonarCube with existing CI/CD pipelines can sometimes present a convoluted challenge, as it requires aligning the tool's analysis capabilities with the workflow of build processes. This often makes it necessary for troubleshooting plugin integrations and script configuration to ensure seamless automation. Looking at Jenkins requires extra effort for integration with CI/CD pipelines. So for Jenkins, it requires a deep understanding of build environments and may make it necessary for custom scripting or pipeline configuration. Integration often involves more than just Jenkins itself, as it must communicate effectively with other tools in the development stack, such as version control systems, build tools, and deployment environment. Looking at the third aspect, which is time-consuming reviews. So for SonarCube, it has false positive lead to time-consuming reviews. So while the automated detection of code quality issues is invaluable, it can also lead to an overhead of effort as team work through the false positives that are inevitably raised. This makes it necessary for a review process that, while thorough, can be time intensive as it requires manual investigation to distinguish between actual issues and false alarms. Now, looking at Jenkins may require significant time for managing plugin compatibility and maintenance. So, the operational overhead with Jenkins is more about pipeline maintenance. The time required to manage and troubleshoot Jenkins jobs, especially as the number and complexity of the job increase, can be significant. Ensuring compatibility between various plugins and the core system with each update can consume considerable resources and attention. Looking at the next aspect, which is plugin dependency and management, for SonarCube may encounter limitations and complexities in managing plugins and dependencies. So the dependency on plugins for additional functionality can introduce a layer of complexity, especially when it comes to version compatibility and managing updates. This can lead to situations where a plugin's limitation dictates what can or cannot be analyzed, potentially impacting the overall utility of SonarCube in a project. Now looking at Jenkins, plugin compatibility issues and maintenance concerns. So with an extensive catalog of plugins, Jenkins provides a rich ecosystem, but it also comes with the risk of plugin sprawl. Dependency conflicts or breaking changes in plugin updates can lead to significantly maintenance challenges, and the task of keeping a Jenkins instance streamlined and up to date can be daunting. Looking at the final aspect, which is management complexity. So for SonarCube, management complexity may increase with scale. So the administrative challenge grows with the scale of the enterprise. For large organizations with multiple teams and projects, coordinating across different instances of SonarCube, ensuring consistent rule sets and policies, and managing the security and access control can become an administrative burden. Looking at Jenkins, complexity increases with large job configurations. So the complexities in Jenkins management often stem from its use in large-scale environment with many jobs and distributed systems. Scalability brings complexity, and managing a Jenkins cluster or high number of jobs efficiently requires ultra careful organization and may demand dedicated resources for system administration. So in short, while SonarQube poses a challenge mainly in the realms of setup complexity and code review management, Jenkins' primary hurdles lie in pipeline configuration and plugin maintenance. Both will require a commitment to learning and ongoing management, but the investment pays off in their powerful automation and analysis capabilities for a seamless CI/CD experience. Balancing these tools' strengths and against their challenges is crucial.
Now looking into the key applications of SonarCube. So the first one being quality assessment. So SonarCube excels in its core application, which is code quality assessment. It evaluates code against a vast set of predefined quality rules, which includes coding standards, potential bugs, code smells, and many more. This process is actually vital in maintaining clean and maintainable code, which in turn leads to more robust and reliable software applications. Now, moving on to code coverage analysis. This is another key application of SonarCube. This measures how much of your code base is covered by automated tests, which is essential for understanding the effectiveness of your testing strategy. SonarCube's analysis helps pinpoint areas that are undertested and potentially risky, allowing teams to direct their testing efforts more efficiently. Now moving on to the security analysis. So SonarCube security analysis capabilities are actually extensive, identifying vulnerabilities and security hotspots before they can actually be exploited. This preemptive analysis is actually crucial in the development lifecycle, helping safeguard application from potential threats by integrating security into the development process rather than addressing it after the fact. Now, moving on to the technical depth. So, technical depth can accumulate quickly and can be difficult to track. SonarCube provides an insightful way to manage technical depth. It quantifies depth and provides actionable guidance on how to address it, making it easier for teams to prioritize and also tackle depth repayment tasks effectively. Now, moving on to the last application that I would like to discuss, which is the project size. So, SonarCube actually provides a comprehensive size matrix to get to know the scale and the complexity of the project. By analyzing the lines of code, function points, and complexity, it gives a clear picture of the project's magnitude or the size. These metrics are important for planning maintenance and actually allocating resources effectively, and also making informed decisions about refactoring efforts. Thus, with SonarQube, teams can maintain a view of their code base size as well as structure, ensuring efficient project management.
Benefits of SonarCube. So one is that it reduces complexity and vulnerabilities, as its ability to review security hotspots and detect potential vulnerabilities. It uses a set of rules, and as such, it helps indicate potential vulnerabilities which you will be able to fix before before actual problems, and it also detects them much earlier. Second, it increases productivity as it reduces the scale, cost of maintenance, and risk of application. As such, it removes the need to spend more time changing the code, and rather you'll be more working on the code. Third is reduces code duplications, as code duplications in SonarCube is basically that you have the same or very similar codes repeated in different parts of your program. As such, it helps address this code duplication, and you can create a single function that handles both conversions, which is it helps you fix instances of duplications, as such improving your code's quality and readability as well. Next is decreases application size. So SonarCube enables team members to reduce application size with decreasing code complexity and maintenance time and cost, and makes it easier to read. As such, the better quality is it's much more simpler it's better quality, however it's simpler reading. As such, it decreases application size. Next is enhances quality management. So, well, the quality of the application is directly tied to the quality of the code. As such, SonarCube manages the quality of your app's code, and it becomes part of every phase of the development. As a result, SonarCube increases maintainability and reduces costs associated with technical debt and having to manage it. Last would be it's built to scale. So scale with ease, as in As of yet, there has been no limit to this tool's scalability, as whether you have 1 or 1,000 applications with millions of lines of codes, SonarQube has been able to perform at a high level and provides in-depth analysis of its code usage.
In conclusion, choosing the appropriate software measurements and metrics tool holds significant importance for organizations. Various factors such as team size, project complexity, integration requirements, and budget constraints must be considered during the selection process. It's essential for teams to thoroughly evaluate their specific needs and financial resources to identify the most suitable tool. The selected tool should not only align with the organization requirements but also contribute to enhancing productivity and workflow efficiency. By making a well-informed decisions, team can effectively monitor and analyze software metrics, leading to improved performance and better decision-making processes. Hope you gain a knowledge about SonarQube software and also how to select an appropriate software metric tools. Thank you for your time and consideration. Have a wonderful day.